Okay, I'm going to explain the flow chart for the back conveyor driver. Right, let's starting from the start icon. Okay, first we had to initiate port for the LED, and then before we meet the first stage, which is to light up the LED one, we had to make sure the switch is whether it is open or closed. If it's closed, it will immediately turn on LED and it will display value of 1. Otherwise, if you it will turn back until the switch, it keeps repeating until the switch is closed. Switch is closed, then the LED will be light up immediately and display 1 value. Okay, then the initial, you have to initialize the port and icon for LED 23, and then do the addition analog to digital conversion. All right, and then there's one condition need to be done, which will determine whether you move to stage 2 or 3. Right, stage 2 is when you adjust the potential meter between 0.4 volt to 0.6 volt. It will display 2 and turn on LED 2. While the stage 3, when potential meter is adjusted to more than 0.6 volt, you turn on LED 3 and display 3 value. Both outcome will not affect the LED 1. LED 1 is still remains the same, never affected at all. So when the value of 3 is, for example, for this case, if the value of 3 is unable to be detected instead of other value, especially below the value of 3, then it will choose to do the stage 2, which is turn on LED 2 and display 2 value. While if it successfully detected 3, then it will turn on LED 3 and it will display value of 3. Okay, and then for the stage 3, we still have like few parameters to be done, which is to initiate the PWM timer and duty cycle. Once it is done, the fan will be activated, and this cycle will be returned to this outcome for stage 2 and 3 will be turned back to the stage 1, because stage 1 is some sort like a guideline, like because LED 1 has to be light up at whatever outcome. So I decided to put both outcome stage 2 and 3 to stage 1 as a cycle. Okay. Okay, now move on to the code. All right. This code is not too long, not too short. All right. I'll just briefly explain about it. Okay, we need to initialize the type, the name of the PIC name, and configure few parameters. The buffer one is to define a variable to hold the value. The awk 0 times 4 is usually made for interrupt. Okay, and then all right, LED 1 I make it as the first stage. All right. Okay, starting from the BSF status RPO, we're going to access the bank 1. Then CLRF is to clear trees and make port D as the output. Then set port A, RA0, RA1, RA3 as analog, while others become digital. Then select display 2 to BCF 3SAR2. Okay. Then accessing bank 0. Then clear both port D and port B and set port A. After all this, the value of 1 has appeared. Okay. Then move on to the LED 2-3, which is like combination of the decision to go to stage 2 or stage 3. All right. Okay. Right, let's start. Right, register band 1 is selected. You see, as you see, port B and port D is made as output. Then this will, okay, then this move LW binary number of 000000100 is left justified in port A0 and port A1 as analog. Then set A4 as digital output. Then another register bank 0 is selected. Alright, and the most important thing is the add core 0 is configured as a analog to digital conversion, which going to happen in the next part, which is in the main loop. This is doing the whole ADC conversion. All right. Once it's all done, this bit will change to 0 when it is completed. All right. This one, the 8-bit MSB is copied to buffer, which is to buffer 1. Then in the check part is send. Sorry, it is copy the value to buffer 0. Sorry, to buffer. Sorry, I repeat again. In check loop, the move F buffer 10 is meant for copy to display, while to the another buffer 10 is for copy to W register for processing. Okay, so right. This binary number sub LW 01101111 is the binary number created based on the main voltage, the 0.6 volt. It be because it's used for the ADC conversion previously. All right, and then the bit C, whether it's checked whether it's set, and once it's clarified, once it's done, you will either determine to 2 display or 3 display. All right, 2 display. If it's detected the 2, then you display the value of 2. If it's 3 display, it means if the value of 3 is detected, then you straight away paste it on the channel segment display. Oh, sorry. 2 display and 3 display are both displayed on the channel segment in one channel segment window. All right. Okay. For the fan part, only 3 displays connected to fan icon, while the LED one is while dual display is only go back to LED one, because one of the requirement for the stage 3 is during the stage 3 it will turn on the fan with the duty cycle of 40%. Okay. All right. Okay, move on to the last part, fan. All right. Band 1 is access, set CCP1 to RC2 as output 2. Then set the PWM period, which is PR2 of 61.5. Another band 0 is access. CCP ICON to BW mode is set. Then this value has been made according to BWM period PR2. And then move L8 MSB to CCP-RIL and 2 LBS to CCPI 1 CON 5 to 4. Okay, then clear TM timer 21F flag and set T2 con on and with prescaler 4. After this, the fan will be reactivated. Then it keeps repeating, go back to the LED one and repeats the whole cycle. Okay. I'm going to show the demonstrate. Final part. All right. This one will be the start and stop button, as you can see here. I'm going to start now. Okay. This one, there's 2 as well, but you can see the 1 is the one that shines a lot, is the number 1. Means the stage 1 is now being affected. The LED one value of 1, it doesn't affect it, whatever account is. Okay. Okay, stage 2. Okay, I jump to stage 2. All right. You notice just the potential meter. Potential meter is to 0.4 to 6. Okay. After I pass through this, it turns to 3. I go to the right side, it comes 2. Okay, and then about the LED, if you notice the LED port D, this D1 remains the same, but the D1 and D2, both of them are shining back. Okay, all right, and as well, right, one more thing, the cooler, the power, what? Okay, when I go to the 3 value, which is stage 3, the cooler is fully operational. Right, go turn back, it's slightly a bit lack of energy, lack of power, because the PWM duty cycle is cut down the voltage use for the operation of the PWM. You see it's slightly weaker, right? Okay, this okay, and then for the final stage, the first press of the stop button is this one. Okay, and that's it. Thank you.